to meet you all, and today we'll be talking about weatherproofing with Rainscreen Facades. We'll be talking specifically about moisture management done right. The structure today is a presentation in 8 sections. There will be 45 minutes presentation for me to tell you about these products and principles. At the end, we will have a 15 minutes QA session. Please send your question to the QA box in the Zoom menu, and we will try our best to answer all those questions. If not, they will be answered on a follow-up with each one of you. Let's start with the ventilated rainscreen systems. You probably are familiar with the terms. Well, in simple terms, our rainscreen system is just as it sounds, a screen to protect against the rain. Most of the rain and the moisture is prevented from penetrating into the wall assembly. The water is allowed to drain out, and moisture can easily evaporate from an air cavity behind this first line of defense. In modern days, a rainscreen is a system designed to manage moisture by creating an intentional gap between the exterior cladding and the primary structure of the building. The air gap allows for 2 primary functions: drainage. The rainscreens direct any bulk water that penetrates the outer cladding down and out of the building, keeping moisture away from the insulation and framing. Ventilation. The gap facilitates the air circulation, which helps drain out any residual moisture, reducing the potential for mold growth and maintaining integrity of the building's envelope. There are 2 main types of rainscreen systems: drain and back ventilated, and pressure equalized, or also known as compartmentalized. Among these types, the drain and back ventilated is probably the most common and is the simplest among them. It allows water and moisture to escape from the air cavity between the cladding and interior wall assembly. This cavity is open at the top and at the bottom, and it is the most commonly used within rainscreen systems. The most complex one is the pressure equalized rainscreen system, which is a little bit more scientific. The air from outside the cladding is allowed to enter and pressurize the compartments, thereby blocking the infiltration of water. The aim is to equalize the air pressure inside the cavity with external pressure, preventing rainwater from being forced into the building's air and vapor barrier. Pressure equalized rainscreen systems often used in high-rise buildings and in areas prone to strong winds, where wind and air pressure could vary across different floors or areas of the building. In this system, the top of the rainscreen cavity is not vented. Vertical cavities are intentionally sealed to allow the chambers to fill with air when exposed to high winds. As the wind fills these chambers, the air pressure inside equalizes with the outside pressures, preventing the water from being given up through the cavity. A bit of history about rainscreen systems is that was something that protecting the walls by means of a screen as a principle is not definitely a recent idea. The concept of a rainscreen system goes back to centuries of history, originating in Norway. These earliest rainscreen systems were initially a mere intuition, created through experimental and rather than through scientific research or knowledge, using wood cladding, using tight seams between boards, leaving an air cavity behind the ventilation at the top and bottom of the facade to enable rainfall to flow away and moisture to evaporate into eaves and above to protect stone walls in modest building first. Moving forward, it is in the 1940s that further research concluded that using rainscreen cladding was the best option for exterior wall assemblies, because walls constructed of porous materials will eventually crumble if exposed to moist weather conditions for an extended time without being protected by water repellent. Covering these porous materials with an impervious product will result in ideal conditions for mold and mildew, so there had be to a path for water to escape and moisture to evaporate. With the rainscreen, the moisture evaporates due to natural convection in the air cavity between the rainscreen and the substrate. The double layer principle construction of this type of wall assembly concept was born. with an outer surface to control, but not completely to prevent the rain and moisture penetration. What happens is that the interior element of the wall assembly provides the insulation value, limits the air leakage, protecting the building, and prevents vapor penetration into the surface of the building. This evolution is now today bringing benefits for the Rainscreen system. Those ones could be superior weatherproofing, protecting your building, condensation control thanks to a combination of cavity and management and breathable permeability, long-term durability, and overall thermal efficiency from the building. Now that we have talked about the principle of Rainscreen systems, we can focus on weatherproofing compliance and challenges. We know that weather conditions are becoming more extreme and unpredictable. Our Rainscreen systems are then required to be even more durable. With climate changes as an ever-growing concern, the use of Rainscreens to an environmental advantage is now being considered in the development of new products, building processes, and industrial regulations. There are different forces at play that helps on our building enclosure. So far as the building enclosure is concerned, water is insidious, can undermine the structural integrity, the bones of our buildings, and deteriorate its exterior. The additional expansive pressures of the freeze-through cycles and embedded moisture can literally crumble building facades. Entrapped moisture can also foster mold and rot that can sicken building occupants. It is critical to prevent water from seeping into building walls and slowly destroying the structures from within. Therefore, moisture-resistant envelope is top priority for buildings, regardless of their age or use. Holes, gaps, and cracks, joints around doors and windows, and porous exterior materials such as brick, stone, and concrete can allow harmful moisture into building structure. In every climate, moisture is a persistent challenge for buildings. Whether it comes from rain, snow, or humidity, moisture can penetrate cladding and damage the underlying structure. Without effective moisture management, buildings risk mold growth and material deterioration, which lead to increased maintenance costs and can even impact occupants' health. To address this, the building codes have evolved to require or encourage moisture control measures that extend behind traditional water-resistant barriers, previously known as WRBS. Rainscreen systems, which are designed to create a gap for drainage and ventilation between the cladding and the building structure, are one of the most effective solutions for controlling moisture. By helping to prevent the water from reaching the interior walls, a Rainscreen system safeguards the entire structure, enhancing building resilience and occupant comfort. In the evolving world of construction, as we witness today, effective moisture management is more crucial than ever. With advances of building codes, increased climate variability, and also greater expectation for building longevity, construction teams are increasingly focusing on building envelope solutions to protect structures from damaging effects of water infiltration. One of the most reliable ways to achieve this is through a well-designed Rainscreen system. Rainscreens, which offer drainage and ventilation pathways, prevent moisture buildup and protect structural integrity over time. So, one of the first things to know is when selecting the best Rainscreen system is knowing what are those factors that include climate conditions, building height, wall assembly type, and the cladding materials used for your project. For instance, if you look at the overall Australian territory, regions with high humidity or frequent rainfall, an exterior cladding application might be optimal for managing moisture behind absorptive materials and prevent moisture from entering the building, for a project focused on maximizing thermal efficiency with continuous insulation. For example, exterior framing options can provide reduced moisture management while minimizing the thermal bridging in so-called breathable walls. Fairview has now considered this approach and focused on provide non-structural components with an approach which is intention and the mission to supply everything from the back of an internal linings out for a full system that can help to deliver a design intent and all the functionality when concerned to a ventilated cavity. So Fairview can assist with materials and full system adhering to compliance to Australian standards, National Construction Code, technical resources available, quality control, and active industry involvement. What is included in Fairview offer will be membranes, subframing, rainscreen wall insulation, and other elements like fixings. All those elements, they are part of the wall build-up, which is the rainscreen system, the ventilated rainscreen system, the tool that designers, engineers, and builders can use to protect the walls and manage the moisture and the condensation. Moving now to the elements that are found in the wall build-up and an eye on how Fairview can help during the design. We consider our wall build-up, we leave our dry lining behind, and we move to the sarking. So this is the best and the first main barrier against water ingress. Moisture management is closely linked to the environmental conditions, as mentioned before. The National Construction Code helps using climate zones in setting performance requirements. The overall national territory has been divided in 8 zones, from the tropical areas of the north end, zone 1, where you have high humid conditions outside, to the most populous area of the southeast, which are included in zones 5, 8. Here you have mild winter conditions, and usually the moisture is coming from inside, from the warmer environment, especially during winter. Around 50% of the population fall into zones 6, 8, which are requiring a minimum class 4 membrane. So, this is to say that it's important to understand the condensation management flows from the National Construction Code are strictly related to the project requirements and the project location of the building. So, it's important to know what membranes is used in what locations. Fairview can help offering 3 membrane options: standard Vitrafix wall sarking, ultra, and solid decks. All of them, they are class 4 offering vapor permeability in compliance with the National Construction Code requirements, which came, all the change, they came into effect from October 2023. When selecting the right applicable membrane, it's important to know what are the requirements then. So Fairview products, they meet National Construction Code requirements in 2022 about vapor permeability, condensation management need to satisfy. There are 3 level vapor permeable, 4 in case of the sarking ultra, and all this sarking needs to be tested. So when it comes to selecting the right sarking, it's important to have as many data as possible available. In this table, for example, it's possible to see the key features of Fairview sarking membranes available in the market today. Testing data as per Australian standard and technical data sheets are available to support compliance of this product. Most market and premium sarking options are available depending on project requirements, and they are available for competitive offers, and they serve as a principal defense against water ingress. So it's very important when selecting the right sarking. Moving forward, in our wall build-up, we'll leave the sarking behind, the back wall, and we now enter the cavity. The cavity, as we saw before, is very important, which is where all the moisture, all the condensation is kept and removed. So to support panels, it's also important to select to have a design subframe system. Fairview supply Vitrafix profiles. So it's a range of fully component separating accessories. Structural and non-structural elements are available, hand-in-hand with cladding options, in achieving a full wall build-up system solution tested and compliant. The overall offer started with the Vitrafix subframing with the engineering assessed profiles, compliance with Australian standard, product quality control, and the range includes perforated and conventional solid profiles in order to accommodate different cladding zone depending on the requirements. It's important to know that the minimum depth in the cavity zone is very important. There will be some guidance from the next National Construction Code issue that we are expecting later this year. However, 25 millimeters up to 35 millimeters are usually the optimal depth for a cavity to allow ventilation and drainage. behind the cladding panels. When selecting the profiles, it is also good to know what are the testing and what are the engineering assessment that have been provided by supplier. For Fairview and Weatherproofing profiles, load testing assessment and span tables are available to support design and to assist the facade engineers. Materials meets the Australian standard for G2 steel. Independent lab batch testing to AS1301 are available, and they will be offered for the market. When considering a cavity, it's also important that the cavity barriers are an important part of the system. Complement the functionality of perforated tapetti by balancing fire safety requirements when the ventilation is required. Fire cavity barriers ensure that the building facade and wall system perform effectively in terms of both safety and durability, whilst perforated profiles, they enhance the ventilation. Fire cavity barriers, if necessary, the breaks to stop the spread of flame. This will be recommended when installing perforated pads. Fire might spread more quickly to perforated pads, but can only occur with a level fire that can be controlled thanks to the installation of the right fire cavity barriers in the system. Steel is a product that is available among the Weatherproofing files. It benefits from perforated subframing when installing a system, would be for ventilation and drying, pressure equalization, reducing the chance of moisture being drawn into the cavity or having moisture sitting on top of an horizontal profile, for example. It helps for the thermal performance of the wall and maintaining small growth in the cavity. The perforated pads work with Weatherproofing sarking as a system to evacuate moisture from the envelope and the cavity. As an example, G2 Z275 engineer certified perforated pads are available with 1.2 BMT thickness, 24 millimeter tapete with a pitch of 44 millimeter center to 12 millimeter diameter for perforation, or 35 millimeter tapete profiles are also available. In order to accommodate installation of a linear system, we also offer, for example, S-button elements. Still, they are engineering assessed, designed for the linear range, our stream Vitrolock. Depth of cavity up to 35 millimeter can be accommodated. With a pitch of 74 millimeter centers of 90 millimeter diameter holes, they allow for ventilation. They help ventilation to the cavity. It's also available in the Weatherproofing range of products, aluminum profiles. This option, which is still engineering certified, premium corrosivity resistance, lightweight compared to steel, available in gray 6060 aluminum, extruded profiles, 2.5 BMT thickness. It's available in two formats: top at 24 millimeter solid only or perforated, and top at 35 millimeter solid and perforated. So it's a valid alternative when steel cannot be used depending on project locations or weight of project requirements. Then we have also other aluminum profiles that can be used as part of a system. Still standard Z angles, high and low, depending on the extending Z angles, developed for project remediate, for example, as part of a non-combustible cassette panel system. Strengths around corners of a cassette, they are available as angles 60, 60, 25 extruded, 1.6 millimeter BMT thickness, extended like same angles, same thickness, CJ Johnson, adhesive tape reinforced, rotting cassette, and available also has powder coated design angles, depending on the project requirements, suitable and compliant. Within the cavity, it's also possible to install the insulation. This element is very important. So non-combustible stone wall insulation could be added as an element in your wall build-up. You have to include a thermal Rainscreen on acoustic product into the interior partition wall. So the rock wool insulation is certified as a non-combustible product, tested to AS 5030.1 and AS 1530.3. And also comes with environmental product declaration documents, APD, available. Rock wool Rainscreen insulation, which comes to our value range from 0.75 to 2.5. It's a moisture repellent and vapor permeable product. which means it can be easily installed outside of the cavity, so it doesn't need to be protected with arcing. Makes an ideal product for new buildings or also whole buildings, which are looking to implement to improve the thermal efficiency of the facade. It meets the National Construction Code to satisfy vacuum availability requirements, so class 4, and 1.2555 micrograms per second. It increases the dew points, and it's a non-combustible. How the insulation could help in the moisture management condensation. So what happens is that whenever you have a cold wall, the moisture that is traveling within the wall could reach the dew temperature. So if the wall is too cold, the moisture inside could condensate, creating a buildup. If you add the insulation to the cavity, then you create a warmer wall, you increase the dew point, which means the interstitial condensation risk inside the wall will be avoided. There will be no moisture buildup and no risk of mold trapped into the wall layers. Moving back to the dry lining and the overall wall buildup, you can still use a different insulation. So for example, rock wool safe and silent per insulation used for drywall partition applications is designed and manufactured to achieve excellent acoustic insulation performance in all types of drywall partitions and configurations. It's available among the product range from Fairview, and it's also used to fight the common source of noise at 250 Hz, which are including insert type machinery, for example, HVAC systems, pumps, engines, and vibration from equipment levels. In architectural and environmental context, this kind of noise derives from ventilation systems, resonance of building structure, and mechanical equipment. So they are quite common, and this product can help to improve the overall noise insulation. In order to install this product on a wall build-up, Fairview can also supply fixings. So mechanically fixed slab into the wall, depending on the thickness, are available sizes of the fixings to cover the insulation range. Moving now from the cavity and insulation, we move to panels, Vitrafix fixings. Fairview can offer, as a part of the full range of system, also a range of fixings. We have a product tested that can be used, for example, focus paper system. Backing rod, rivets, screws, and caulking products, they are available as part of the standard supply. When it comes to links behind the cavity, which is being well sealed, the first choice for architects is what type of material can be used on the outer skin. So the aesthetical decision, its design intent, needs to be supported with a selection of material that can also protect the wall. So if you remember the principle, the outer skin is the barrier, the first barrier to stop the rainwater to penetrate and to get into the cavity. So the Rainscreen assemblies have proven highly effective in minimizing water damage and adding insulation to the building as an overall system. They help to create beautiful, sustainable, and long-lasting structure in the process to protect our collective architectural legacy. So it's important to have selection of material as part of a full system. Fairview in the past has developed several types of system and materials. So from traditional metal panels, including also natural products nowadays. We have, for example, Fairview Clayton. Clayton is a full system made of terracotta tiles. They are available in many colors, textures, and shapes. The manufacturing process is for extruded tiles. So these tiles, they are fire and kill, and they are non-combustible. They protect and they offer a very durable outer skin for your building with a high thermal mass and very good thermal performance. It combines the charm of terracotta with modern production techniques, and it comes with a 50 years design life. Other natural products from the range, from the Fairview range, is our Genesis system. Genesis system is made of fiber panels, compressed fiber cement. So high quality, refinished true color fiber cement cladding panels manufactured in Europe. They are come with a face fix system with the color riveted match fixings, and it's available as a Genesis signature with a 20 years warranty or standard Genesis range with a 50 years warranty. Smart Brick system is the innovative product that Fairview is offering for architects. They are looking for alternative to traditional masonry brick wall. So it's an innovative ventilated low screen system. So you have an outer skin made of clay bricks, non-combustible, and all the benefits in a ventilated facade behind this outer skin, with all the benefits of having ventilation and a sarking protecting the back wall. The option is for a grouted traditional brick facing or modern grouted mortarless brick facing, which help with a quicker installation as well. It's a lightweight system with a weight of just 55 kilos compared to 200 kilos of a traditional masonry brick wall. All the benefit of moving this system or installing this system to a high-rise building and transferring less stress to the building structure, for example. You also offer higher design flexibility, since it's possible to be installed onto any feature in the building and also used to create curved facades, for example. Among the metal family of products, we can find Vitridril. Vitridril is a solid 3 mm aluminum product used for cassette panels. It's a non-combustible, is suitable for type A and B construction, and it's a PVDF or FEV panels. So it's a pre-finished product that can be easily used for cassette panel system. An alternative for engineers and architects, they're looking for an allied version, is our G2. This is an engineering panel designed for high performances of facade materials. Half the weight of traditional solid aluminum, 5 times more rigid, and has 70% greater resistance to oil canning. Still available as a part of a full system, which is combined with all the profiles available for Fairview range. We also have our linear product, which is made of our Stream. Stream is a system where you have extruded plank, aluminum plank on the outer skin of your building. It comes as a finished product. Interlocking planks can protect your wall from water entering into the cavity. This aluminum, as such, is a non-combustible material. Contemporary solid 66 grade aluminum interlocking, available in anodized or powder coated finishes to support any design intent, conceal fix, and linear aesthetic. Now, time to see a few case studies that we'll be looking for our project. The first one is Downturn Street in Halston Park, New South Wales. It's an example of a new building designed with a drain and back ventilated rainscreen system protected by a lightweight aluminum cladding. Our G2 has been selected for the outer skin with closed joint, protecting the cavity from any water ingress. Any moisture or any condensation that will be coming or trapped in the cavity will be allowed to travel to the wall thanks to our breathable plywood membrane, but any water will not enter into the wall buildup. And it's important to say that designing rainscreen system is very important, as well as a correct installation. Supervising installation procedures and document is fundamental to achieve a moisture and control management system without any failure. So facade engineers can assist in ensuring this is done correctly and in compliance with standard and design drawings as well. Another example of rainscreen, ventilated rainscreen systems is in Victoria. The Clyde Health Hub, North Clyde, Victoria, is an example where the architect has selected a lightweight system, innovative lightweight system, which is our smart brick, in lieu of a traditional masonry brick wall. So the overall depth of the wall has been reduced. The appearance has been ensured by the use of concrete brick slip with mortar. Behind this effective outer skin thin, there is a cavity. So ventilation and drainage is ensured. to a 35mm cavity, and the sarking on the back will protect the back wall from any water ingress. There will be no time for questions, probably. We'll open now the section. So, first question is about precast wall and how is moisture prevented, since this is a facade closed system. Usually, when you have a precast wall, your moisture is actually coming from inside. So the best will be your wall, your precast wall will stop in water ingress, is a sealed outer skin. But you still have possibly some moisture depending on what is behind your precast wall. So either a vapor control layer membrane will be required, or you allow the vapor to travel to the second layer, wall build up, and get removed by the cavity. Another question is what is the benefit from the G2 engineered aluminum? So the benefits overall is you have a lighter system, a tested lighter system. This could be a great advantage when you have, for example, a remedial project. Sometimes you have to remove a combustible cladding, which is made of lightweight panels with a combustible core. So if weight is one of the requirements for the project, and you are keen to remove only the panels, you can replace lightweight combustible panels with the lightweight non-combustible option. G2 is the right answer. So, for example, if you are not allowed to have a heavier cladding system, or you want to minimize the issue of replacing the subframe of the combustible system, you can recreate the panel layout with G2, considering and using the same subframe. Next question from Robert. For ventilated cavities in bush fire-prone areas, do you have member trims of ember guards? Ventilated cavity in bush fire-prone areas. Ember trims or ember guards. They are part of the fire safety strategies in this case. So we can look at that. They are not part of the Fairview range at the moment, but we are looking at that, especially because there will be requirements to introduce air cavity into the systems. And as such, fire cavity barriers will be considered as part of the system. So we will be looking at this one, and happy to get back to you, Robert. So another question is, does it perform well thermal speaking, considering thermal bridges? Overall, any Rainscreen cladding system needs a subframe, an aluminum subframe, and as such, this is installed onto the back wall. So this is actually a relevant question. The best way to reduce the thermal bridges is to adding a thermal breaker. So structural element which simply separated the subframe, the metal subframe from the back wall. This will minimize the contact between the metal and the back wall, and it will help to reduce the cold bridges or thermal bridges across the facade. And Fairview will be looking at a thermal breaker as part of the supply range to complete the full system. I think this one was also a question about thermal bridges, about G2 aluminum. Usually the thermal bridges, whatever is your cladding, is located in the contact between your subframe and the back wall, or for example, the fixings penetrating the back wall. So whatever is the system, either it is a G2 or stream, it's important to minimize the point of contact or the area of contact between the aluminum subframe and the back wall. So thermal breakers is the right answer for that. You're welcome, Robert. See if I'm missing any question. Apologies for that.
Luca, I'll just jump in and say that David and Jocelyn have raised their hand. David and Jocelyn, if you have a question, if you wouldn't mind just popping it in the Q&A box, just so Luca can address it.
Thanks, Emily. Okay, Paul. Thanks, Paul, for your question. Paul is asking if we do require fire break between floor levels. In principle, yes. When you do have an open air cavity, what you need to do is try to create some sort of compartmentalized it. So in order to avoid the chimney effect, the good use is to use some cavity, horizontal fire cavity barriers at floor levels. What happens is that they will act only in case of fire. So usually you have a cavity, an open cavity, but minimum thickness is left open between the cladding and the back wall, or in this case, between the cladding and the fire cavity. In case of fire, the fire cavity will expand, closing the gap. So the minimum of the restricted depth of the cavity is just a floor level, so just equal to the height of the fire cavity barrier. The rest of the cavity is a full depth, so the air can keep circulating behind. So as a part of a fire strategy, fire safety strategy, I would say that the fire break are required at floor levels. And depending on the design intent and the layout, it is possible that vertical fire cavity will be required as well. I hope it answers your question, Paul. You're welcome, Paul. I don't know if there is any further question, or feel free, drop me here and we'll get back to you. Definitely, we will look at the question and the requirements for the question from Robert about which fire appears into details. You're very welcome, Isabella. Thank you for attending the webinar. Thank you, everybody. Let me check. There is I've got 3 raised hands by David, Folk, Jocelyn, and Ilaria. If you would like to drop your question in the section, I'll be happy to answer, or I will contact you directly if you prefer. Otherwise, I will say thank you, everybody. I'll give some extra minutes if there are any further questions. And after that, we'll wrap the session. Thank you, everybody. Feel free to reach out if you have any further question, any doubt. We're here to assist and to support you in the design and technical questions. Thank you. Have a good day, everybody.